A very basic concept when dealing with forces is the idea of equilibrium or balance. Let's define what equilibrium is and let's identify its types and conditions. Equilibrium is a state where all the forces that act upon an object are balanced. So the sum of all the forces acting along the vertical and horizontal axis respectively must add up to 0. So in our image, in our example, there are two characters playing tug of war. Okay? So since both forces are equal, it is said to be in equilibrium. However, if one would exert a much greater force, there would be a disturbance in our equilibrium. Okay? Now, where do you see equilibrium? So, when you see a book lying on a table, there is equilibrium. The weight of the book acting downward is actually balanced by the upward reaction of the table. Okay? Now, there are different classifications of equilibrium. So, let's have our first classification. So, equilibrium could be identified or classified as dynamic or static. When we say dynamic, it is a state where the body is in equilibrium but continues to move with uniform velocity. So, our animation here is a ball moving with a uniform velocity. Okay? So, dynamic meaning it is moving. While the other type is your static equilibrium. So, it is a state where the body is in equilibrium while being at rest. Okay? So, our example there is our picture frame hanging on the wall. Or, you may also observe your static equilibrium in the other things on the table in the picture. Okay? So, another classification of equilibrium is we have stable, unstable, and neutral equilibrium. Okay? A body is said to be in stable equilibrium if after a slight tilt or after a slight movement, it returns to its previous position. So in our image, our example is a ball, which is the pink or purple ball. And you now have a sphere, which is represented by the yellow circle. Okay? So when you put the ball, the pink ball inside the yellow sphere, and you try to tilt the ball, when you try to tilt the sphere, so the pink ball would go back to its previous position, or there's a tendency for it to come back to its original position. Okay? So when a body is in stable equilibrium, its center of gravity is at its lowest position. Okay? So when it's tilted, like in our example, its center of gravity actually rises, but it returns to its stable equilibrium as long as the center of gravity acts through the base of the body. Okay? So, yan, that is our example. Other examples of stable equilibrium is when you see the chair lying on the floor. Okay? So, when you do a slight tilt on the chair, diba, it would still go back to its original position. Okay? So, if you have observed the heavy base of the vehicle, diba, it's under the vehicle. Okay, let's say a car. You would see most of the heavy parts of a vehicle underneath or near the ground already. Okay? So that actually helps the vehicle to prevent it from what they call this? Prevent from having accidents. Diba, for example, when the car is turning to the right or turning to the left, the car won't fall down. Okay? So, hindi siya natutumba dahil may stable equilibrium. Kasi nga, yung center of gravity is lower. Okay? So, those are some of the examples or an application already of your stable equilibrium. So, next we have your unstable equilibrium. Okay? So, if a body does not return to its previous position when sets free after the slightest tilt, it is said to be in unstable equilibrium. So, in our picture, in our image, you have now the pink ball on top of the yellow sphere. Okay? So, obviously it would not achieve a stable equilibrium because it has the tendency to fall down. Okay? So the center of gravity of your ball, of the pink ball, is at its highest position in the state of the unstable equilibrium. Okay? So as it moves around, it could not return to its previous position. Okay? Now, the last one, we have your neutral equilibrium. So, in neutral equilibrium, all the new states in which a body is moved are the stable states in the body, and it remains in its new state. Okay? Meaning, if a body remains in its new position when disturbed from its previous position, then the equilibrium is said to be neutral. Okay? So, examples of your neutral equilibrium would be the ball moving on the ground, kasi it could not go back to its previous position, but it remains on a new position. Okay? So, a roller or example is a pencil lying horizontally on your table. So, there is neutral equilibrium. Okay? Now, there are two conditions of equilibrium. Okay? So, first condition says that a body is said to satisfy the first condition for equilibrium if the resultant of all the forces or the sum of all the forces acting on it is zero. Okay, so this is what we call your translational equilibrium. Okay, so our example here is a gymnast balancing on the rings. So the force acting or the weight of the gymnast would be one of the forces. Okay, so it's a downward force. But then your rings would also have another force acting on the person or the gymnast. Okay, so these are actually the force. I mean, there is equilibrium because the forces would be canceling out. Okay, so ibig sabihin, balance yung forces. Kaya yung gymnast, hindi siya magfo-fall down or hindi siya gumagalaw. Okay, so we observe here translational equilibrium. So other examples of satisfying the first condition of equilibrium is your book lying on a table. So the force exerted by the book is cancelled out by the force exerted by the table. So if you remember our laws of motion, diba, we have your third law, the law of action and reaction. Okay, so another is the picture hanging on a wall. So these are translational equilibrium. Next, we have the second condition. So a body satisfies the second condition for equilibrium when the resultant torque acting on it is zero. Okay, so torque actually refers to the rotational or twisting effect of a force. So this is called, the second condition actually is called the rotational equilibrium. Okay, so best example for the second condition is when you see children playing on the seesaw. Okay, so yung twisting effect of force would be at the middle part of your seesaw. Okay, so for the seesaw to be stable, I mean, if you wanted to observe equilibrium, as you can see in the image, there are two different masses. Okay, so the lighter child, the one on your left, is at the farther side of the seesaw. Okay, or the farther side of the board, while the child with a much mass should go near the center to avoid or to cancel out the twisting effect of your force. Okay, so when do you see torque? For example, when you twist the knob of your doorknob, or when you try to open the door. Okay, so once you hold the doorknob, then you apply now force. So there's already twisting. There's a twisting effect already. So there is torque. Okay. So second condition examples. For example, we have your force applying on the steering of the car. So if you're driving, or when you're driving a car, or when you're driving yung mga cart yung mga sa festival, mga may ganyan pa ba dito? So, yun. So, when you turn the steering wheel, so there should also be balance, okay? Then you also have your children playing on the seesaw, okay? Now, these are just some of the these are the very basic concepts about equilibrium. Okay, so I hope you learned something from this video as this serves as an introduction to equilibrium. Okay, so I'll see you on the next video. If you have questions, you may comment them down below and then just wait for my response. Okay, I hope you learned something. Bye!